alaikum. How are you? Cool. So let's start. I am Untitled and today I will show you how will you define stone masonry wall using grids. So let's start. And here you can just set the units to keep feet, and now you can define grids over here. So in the grids, let's say that in x direction we have only two grids, the start of the wall and the end of the wall. So two grids in the y directions. So y direction we do not we need, so we can say that only one grid is effective for us. And in z direction or in z direction, I also need only two grids because at the bottom and at the top. Now we need to specify the spacing. In x direction we need to have the space between two. Let's say this is 10 feet. In y direction it doesn't matter how much you keep it, let's say 1 or even 24 is fine. And in z direction let's say it is 12 feet high, right? Normal wall is also almost 12 feet high, so press OK. This is grid which we defined. Now the next thing is we will go to define, and in define we will define some materials. Here two materials are already defined, but for stone masonry we will need to add another materials, and in this material we will have from there, if we see over here we have a lot of options like steel, concrete, aluminium, cold, rebar and all, but we do not have any option for stone masonry or even masonry. For that, what will we do? We will go to other, and even you can rename it to stone masonry. So now what you have to do, we have to define the weight per unit volume for stone masonry. So normally it ranges between 130 to 140 because 145 is for concrete and for RCC concrete, and similarly 120 110 is for soil. So normally it is 140 pounds per cubic feet, so it will be 0.14 in kips. And modulus of elasticity, it could be, you can say keep it now in 25,000 kilonewton, 2500 kilonewton. So let's change it into Newton millimeter because 2500 MPa megapascal was the thing. So in megapascal you can say that it has 2500 megapascal for of the elasticity. Poisson ratio, you can 0.3 is for RCC, 0.2 is for the plain concrete, and similarly 0.15 or 0.10 is for stone masonry or brick masonry. So let's keep it as 0.15 Poisson ratio. And coefficient of thermal expansion, you can depend it, and while this shear modulus will be changed accordingly. So you can just go back to your original units, and if you can see it, it automatically picks the value in kip feet. Cool, no? Anyway, press OK over here and your stone masonry has been defined. Press OK. Now the next thing is we need to define an area, because our wall is can be defined with an area section. So go to area, go to shell and add new section. You can rename it as wall, then shell thin, and in shell thin material name you should have to select material name of stone masonry from here, and membrane, let's say our wall is 9 inches thick, right? So this is 0.75 and the bending is same, keep it as same, and material angle will be same. So you can also set the modifier for the stiffness from here, that but let's keep it 1 for this way and press OK. Press OK over here. Now what we have to do, move to XZ and first go to load patterns, and load patterns set this self weight multiplier load to 0 because we do not want to do the analysis with dead load. So press OK over here. Fine. And now the next thing is, let me just show you it clearly. I am just extruding this view. So now we need to draw that area. For that I am using this quick bar, and here I will select the wall that's already selected and click in between. So on the sides you can see that it has been defined. So press this, you will exit the drawing mode. So your wall has been defined. Now the next thing is, if you run the analysis right now, so what will it do? It will do the analysis on the corners of the wall. So this may be or may not be some the analysis which we required. For that we just mesh the wall, we create meshes in the wall. So what is meshing? We split the wall into different sections, so it will create different points for the software, and it will do the analysis at that specific points. So for that you can just select it, go to assign, and in assign go to area, and to area go to automatic area mesh. In automatic area mesh you can set a no automation. You can use it by automation into number of objects. Here you can define along edge of the point 1 and 2. This will be point 1 and this is point 2. It will cut. So it will shows you that you can divide 1 to 2 into 2 parts, and from 1 to 3 into 2 parts. So now it depends upon you. You can use this. You can use mesh area objects to the maximum size, and then there are a lot of options. So you can use any one. So let me just start with this thing. Along 1 to 2 I want to divide it into 5 parts, let's say, and along 1 to 3 I want to divide it into, let's see, 6 points. So press OK. So look, it is showing me that it has been divided into 5 into 6 parts. You can see this, that 5 cross 6, right? So if you just press over here, now what will we do? We will apply some load over there. So you can apply different types of loading. So for example purposes, I am applying just a unit load on this corner. So I'm selecting that corner and then assigning joint load, let's say force, and the force, let's say I'm applying in x direction of 50 kips, you can say, or anyone. Let's say I'm applying 30 kips, right? That's okay. So 30 kip has been applied here. So now what we have to do, we need to set the analysis type to space frame and run the analysis. So I need to run both the cases and run now. So see, analysis is done, but you can see that our wall is tilted. So you know why? That's why, because we do not assign any support at the base. So for that you just unlock the model. Yeah, okay, unlock it, and now select this lower part and go to assign and go to joints, resistance, and assign this as fix. So you have fixed it. Now if you run the analysis, and now we will see that it will show some stress variation. Yeah, now you can see. So you can see these panels as well. If I just move this to XCV, yes, you can see these panels, the wall has been shifted. So these are some deformation in the wall. So you can see different types of stresses in it, in the shells. So you can see the shell stresses in here. You can see visible as absolute maximum and S11 and S22. So let's see, I am seeing S12 and press OK. So if I just remove this extrusion, it will show me the stress variation contour. Yeah, look. So these are the contours of the wall. Similarly, you can check some other parameters as well from this side. So now the material used in this thing is masonry. So that's how you just model your masonry in the sap2000. That's all. So I hope this will be useful for you. If you like the video, please like it, and do not forget to subscribe the channel. So I will see you in the next video. Till then, Allah Hafiz.